Okay, good afternoon. We will continue with the 2D heat transfer problem or 2D, we call it a scalar field problem. Okay, now, so far we have worked on the triangular elements. So we have 1, 2, and 3. And there could be different kinds. You can also have something like this, or like this. Only difference is you have to choose the shape function accordingly. Yeah? And as we have the Pascal triangle, called the Pascal triangle, and where you have 1 x y, x square, x y, y square, and so on. You have x cubed, x square y, x y square, y cubed. Accordingly, you have to choose, and you have to choose such a way the one at the top should be preferred. So you should prefer this and this over this and this, the simplest way. Yeah, because why you want to do it, you can also do like this one. But actually, if you see the idea here is to make your model or the trial function simple. You have a linear, then quadratic, and accordingly you go ahead like that. So for this one, if you know that there are 3, you will choose 1 x y, means alpha naught plus alpha 1 x plus alpha 2 y, or alpha 1 plus beta 1 x plus gamma 1 y. If you have this, for example, then what do you have? 1, 2, you will have 6 of them. So you say 1, 2, 3, 4, 5, 6 of them. Then you will write, you start counting 1, 2, 3, 4, 5, 6. So for this one, you will have Ni xy as will be something like alpha, let's say call it is equal to A plus bx plus cy plus dx square, right? Plus exy plus fy square. Why? Because you have 6 of them, hence you will have 6 coefficients that you can find out, right? It will give you 6 equations, right? And finally you can solve that, you can find out, right? And of course, when you say Ni, then you write Ai, Bi, Ci, like that, Bi, Fi. Any question? Okay, so for this one is very simple. Similarly for this, if you have some element like that, you can compose your own type, right? So it's possible that you have that, and in that case, can you write? So 1 x y, and you see x square, then it's not symmetric, and you see that being at the middle, it is more symmetric. Hence, you will choose 1 x y x y. So you will write Ni xy as Ai plus Bix plus Ciy plus you can write Dixy. Of course, then you have to find out the coefficients, right, from those equations. But this is the idea. You may have some transition elements, like you will have a 3 node somewhere, some side you will have 3 node. Why transition? Because you may compose some element which may be, say, let us say you have this side 6 noded elements, and from here we are going to start 3 noded. Then this is the transition, right? This is you call it transition elements. Then just to match it, you will have one of the sides may have 3 nodes, right? So it has 6 nodes, 3 nodes this side, in between it will have 4 nodes. And if that is the case, accordingly you have to see which one these will work. Not all of them will work. If you have this, then we have to look for, we don't know which one exactly. Yeah, so based on the situation, you have to look for, or orientation also, it depends. So this will have, because it's not symmetric, you have to see, let us say if it is x-axis is this way, then you know that it has to be x square term, right? But if you have y this side, then you will have y square term. So accordingly, you have to see. And also, if you have x here and y here, then it may be you have to take xy term, and so on. It depends on the orientation, and accordingly, you have to solve it. When you solve it, you can find it. So, but you have to check, you have to try basically. So in that case, you will say this is ai plus bix plus ciy plus bi. It could be either bix square or y square or xy. You have to check depending on the problem, you can find out.
So will we take the axis to be in the particular, like normally vertically, then what will happen?
So you see what I'm saying is, let us say this is the element, right?
Yes.
And then you have here, and you have one node here. Then you know that x square will come here, right? We'll have x square. We'll have x square. Why? Because this is x is quadratic in x direction and linear in y direction.
But if the x is equal to y line,
Yeah, this one.
that's hypotenuse.
This one.
Yes.
Yeah. So then you will have one xy term will be there, right? Then you will have five of them, no? So you will need 5 terms. So one of them will not be there. So in that case, you will have ni xy equal to ai plus bix plus ciy plus di. For sure it will have the x square, right?
Yes.
For sure it will have that, right? And for y also, in fact, you will have. So you will have eiy square as well. There may not be x square.
Why in the y direction we are taking the square?
That's what I'm saying. Either or it will have xy. So you have to find out. That I'm saying. Yeah? You have to analyze, you have to find out which is what. Follow. Any other question?
So it is having y square term because this is.
That's what I'm saying. Just looking at it, you can only guess, because you see here, you have y for y here and y here, right? Meaning that this equation has to be 0 at 3 places. I mean 2 places, right? So same function becoming 0 at 2 places, it has to be quadratic. Otherwise, how it will be in y, right? Similarly for this one, it has to be some value here and 0 is 0 here. Only quadratic can match that. The 2x and 2. Yeah. Okay. So any questions? see, finally, how will you formulate for this one? Let us say the formulation. This is one way you are writing like this one. The other way you can also look at for this one, for example, right? So if you have like this, yeah. So if you want to find out, say, let us see, not like that, but let us. There is also like, let us say this is x, this is y, and you have, it all depends on the quadratic system, right? So let us say this, you have 0, 0, and then this is x equal to a here, and this is y equal to b here. Let's say you have the system like that. Now what? You want to find out the equation of what? N1, N2, N3. How do? You use the minimum number of, well, a curve, minimum number of curve that going to satisfy. Right? So basically, minimum number of curve multiplied together. So for example, if you are here, then if n, this, let us say it is n1, this is 1, this is 2, this is 3. You are going to devise, or rather you are going to make n1, and that should be what? 1 at node 1, 0 at nodes 2 and 3. Meaning that what? If you know the equation of this line, that you make equal to 0, right? Meaning that if you put n1 equal to this line, yeah, and then what happens? What is this? What is the equation of this line?
X y plus y by 2 is equal to 1.
So this will be x over a plus y over b equal to 1. Right? Yeah. Okay. So if that really means what? That really means x over a plus y over b minus 1 equal to 0. This is what I propose ni xy is equal to x over a plus y over b minus 1. What happens? On this line, this is going to be 0. Hence, at node 3 it will be 0. At node 2 it will be 0. But, sorry, it will be rather 1 minus. So that, okay. So, or you write 1 minus x over a minus y minus b equal to 0. So you write 1 minus x over a minus y. Right? Why? Because when you put 0, 0, it has to be 1, no? That's why positive. It should be 1, n1 equal to 1, when x equal to 0, y equal to 0. If you put there, that's why. Otherwise, you will get minus 1. That we don't want, no? See, it has worked. From geometry also, you can look at that, and you can formulate. No necessarily you have to do the work like we have done earlier, like invert the matrix. All those things not required. Looking at that, and it helps you to find out what will be the equation of shape function in the complicated or higher order elements as well. We will look at some example of this. So now look at this. Maybe I start with this one. I don't know, but the same system you have, x and y here, the same element you have, right? So we start with the very easy ones, this condition, okay? So you have like this here. Now you have to formulate, right? Let us say call it 1, 2, 3, and 4. I know this is 0, 0. This is a 0. This is a 0b, And let us say this one is a over 2, 0, let us say, right in the middle. B. How to formulate this one? Now, what it will do in this case is, of course, we have this equation. Now, this equation you have 1 minus x over a minus y over b equal to 0. This is this equation. And then we can propose in this case that n1 is equal to product of two equations. One equation is that another equation is this. And this is what? X equal to 2. Right? And then we can propose this must be, or rather you can also write x minus this minus a over 2 equal to 0, right? You can also propose this way. So n1 is equal to 1 minus x over a minus y over b multiplied by x minus a over 2, and there will be some, you can have some alpha or something, so that you don't have to worry about what is the order of this. Earlier also if we have proposed this multiplied by some alpha, then automatically you will get alpha equal to -1. If you put x 0 at y equal to 0 value, you can find out. Right? So n1 we propose like this now. Right? Simple? Did you get it? Yeah, so you can see that if you put x equal to a n1 at this a0 will be 0, n1 0 b will be 0, because n1 a over 2 0 will be 0 because of this. But n1 is equal to alpha and then 0 0. So 1 minus 0 minus 0 multiplied by x is 0 minus a over 2 has to be equal to 1. Right? And that tells you n1 is alpha is equal to minus 2 over a, and hence n1 xy is equal to minus 2 over a, 1 minus x over a minus y minus b multiplied by x minus a over 2. This is how you do. Just look at the element, inspect the coordinate system, see how it is doing. You just have to identify the two lines, basically. Accordingly you multiply them. By the way, all these things are what I think, not from your book. It's the inside I'm giving you. This is how I would do. Right? It is not in the book, but this is how I would do, how I would compose.
I multiply those two.
That's what I said, no? See here. I have to find out one equation that passes through all of them, right? Then I can make it n equal to that equation. But what happens is that we cannot foresee, meaning that we can also think about the lines. So we think about two lines that we can find out. I will multiply them. One line is this, one line I'm finding this. That's it. That's the idea. That makes life easier for you, because if you have this condition, let us say you have now this. Now you know which two lines are there. Minimum number of lines you have to choose. If I find out n1, how will you do it?
Y is equal to
Y minus
V
B
by
by 2
2.
we have to do.
This is 1 minus x over a minus y minus b equals to 0, and then
X equal to Y is equal
there will be 3. It will be a cubic.
Y minus B by 2.
This equation, right? And what equation is that? This one is 1 minus x over a over 2 minus y over b over 2. And that will make a quadratic.
to. But indirectly we are doing the same thing, bringing those coefficients.
Yeah.
Like,
Doing the same thing. We are definitely doing the same thing actually, but here it is faster. The coefficient you don't have to invert a matrix to find out. You are doing the same thing. So basically in this case will be n1 xy is equal to right alpha 1 minus 2x over a minus 2y over b multiplied by 1 minus x over a minus y over b. Right? And you know that automatically n1 will be 0 here, everywhere except here. And that value, you know that n1 0 has to be equal to 1. You put that value 0 here, 0 gone once, alpha equal to 1. So you can put that. That's okay. Any question? Similarly, if I ask you what is the N2, then what will you, how will you find out? N2 will be 2 equations you have to find out. What will be that 2 equations? So you will have one equation this, another equation is this. Or one equation this multiplied by one equation this. Right? One equation this, another equation is this. You should have such a way that you can also have this way, but it will going to complicate. What is the idea here is you should have such a way in this case that you should have only x squared terms and y squared term.
that means if we do by the old method, the other coefficients will become 0. Like if we do this, then coefficients will become 0.
Yeah. Other coefficient will be 0. Yeah. So if you see here, what do we? So this one is from this one, right? This one. So if you see here, which are terms we have? If you multiply here, we have x squared terms, xy terms, and x term, y term, constant term, and x squared term. So similarly, when you are composing the other one, you have to make sure that you have those terms only. Suddenly you should not have y term coming now. Otherwise think that you have to have here either you have this only, not that n1 will have this and n2 will have this and n3 will have this. No, you cannot do it, right? N1 should also have the same thing, n2 also the same thing, n3 also the same thing. So also you have to see.
So if we have like a node, like first node in which all the coefficients are non-zero, so then we know that these all coefficients, like these all like x, y, whatever they are coming.
Sure.
After that we cannot change. But
Yeah, after that we
if
cannot.
we have found the y square, then we can add obviously.
Yeah. So that's why all these things are, you have to see them. Okay? So you have to make sure that the order remains the same. If you have in one, you have let us say 4 noted. If you have, then if you have in one it is coming 1 y x square, it should remain x square only. You should not go to x y in another one, y square in another one. Should be to that one. Accordingly, you have to see the equation accordingly. Whatever the equation. Yeah. Okay.
So here we are seeing the geometry and deciding whether we should take x square or x square or y square, right? So if let's say we don't put that smart step, then the accuracy will change. So this shape function itself is different, right? So we'll get different solutions and
Now there will be a unique way only. You will not get different. Yeah. There is a unique way to have the shape functions. Yeah. So whatever way you do, finally we end up the same thing. If you take here, it's not possible that you have like three ways of doing the same thing. It will be like either x square will work or it will not work. If it doesn't work, then you go to xy. If xy works, then you take it. Doesn't work, you go to y square and so on. It's like that. Anyway, this is just insight basically, so that when you have that, you can also think that way. You can do it. Yeah? Any question, guys? Any question? More questions? Okay. So in this case, also you can have these ones like this, and for this you can have something like this. Right? So if you take like this one, you will have x squared term, okay, but you have to avoid those. So sorry, xy term will be there. So accordingly, we have to think how to go about it. So let me delete it. So let us say this is triangular, and now we have like this. We have x and y, and this like this one only, and we have like this one. So here, let us say this is a over 2, b over 2, and then we have 0, 0, a 0, 0, b. How to go about it? You have to find out n1, then how will you go? Okay, so n1, xy,
X e by 2, y e by 2.
yes, alpha. First, if you write this in terms of xy, then what happens? 1, so minus,
Next one.
no, this one I'm talking about. This equation. So you have to decide which two equations, right? Yeah. So thinking that direction, either you write alpha 1 plus alpha 2x and all, you get exactly the value that you need. No need to think that way. But if you are thinking here, if you are deciding just based on this one, how will you go about it? So alpha 1 minus, you have to basically not necessarily, it will be obvious. Sometimes you have to think basically, but still we are doing it. So 1 minus x over a minus y over b. And then we have to multiply with something. Now, if you see here, if we multiply by x, then x squared term will be there. If you are multiplied by y, then y squared term will be there. Right? So it's not that we will have x, y, and xy. How will you make xy?
So we can make another equation with process to 0, 0 and e by 2 comma e by 2.
How?
Which is at an angle of 45 degrees, we can make an equation.
Make numbers
Like the motion for this.
and complete.
Will not have that. So, okay. So, can you find out two equations? The equation, either you will have this equation or you will have this one. Regardless of which one you're going to take. 2 points if you take, x, y will be there. So you cannot avoid. Here x square term will be there. Either x square term or y square term will be there. There is no other way. So basically in this case x square term, let us say we have this one and then we have like this one. So we can compose it as x 2x over a minus 1, right?
X minus zero.
X.
X minus zero.
So you have x minus a over 2. Right? And we can have the, what is the value of alpha? So we say 1, 0, 0 is equal to alpha, then you have 1, and then you have minus over 2. So similar to earlier, so you can have in 1 xy is equal to this is equal to 1. So alpha equal to minus 2 over a, 1 minus x over a minus y over b, and x minus b over 2. So our n1 is like this one. What about the n2? Let us say n2. N2, this is just one example how I would think. It's not that a hard and fast thing, but sometimes if you are in a hurry, it works.
Zero at a comma.
Yeah. So n2 xy, then how it will work? Now you see here. We have, what do you see? We have x square term, right? And then we have xy term. Sorry, you have x square term, you have xy term. And
X minus constant.
so does it work? That's the thing. Does it work? So 1 xy, x square, xy, y square. And we need 4 of them. Right now, if you multiply them, you get x term as well,
Constant.
x square, xy, all of them. So you are getting this also, this also, this also, this also, this also. Only this you are not getting. So then these are issues. Then you have to go with the original coefficient. You hurt it if it is not too obvious in that case. Yeah. Or otherwise you have to see whether something is really obvious or not. I mean, if you can find out some other way of doing the same thing, it's fine. But
Could
we
we
can
take-
construct one more equation which causes to a by 2 comma b by 2.
And
So
zero.
that we will have y by square come also.
no, cannot do. No, that's the point. No, we have only 4 coefficients. No, so that's why either you will have this or this or this, not the 3.
Sir, could we make a line which passes through a by 2 comma b by 2 and 0 comma 0?
Then
And another line which passes through 0 comma b. That's it. Is fine.
okay. You are saying like this one, this one,
Yes, sir.
like this one. Yeah, it may work.
Two works are by square comes in come.
No, but
All B will come.
no, it will not work because you don't do like this one. Then you will make it 0 everywhere, no? Then it will work make 0 everywhere. That's the thing. Yeah. Okay, so the thing is, it is not very obvious basically. So that's why I'm saying that not necessarily will work every time. This is just inside. That's why I'm saying it's not in the book. This is like sometimes it is easier to see. You can see that. Sometimes it's difficult. But what I'm saying, be careful. This is an example where it's so you have to be careful. Okay. This may have some other method. If you think it may come to you and maybe tell me. Okay. So, yeah.
And if you take x equals a by 2 and y equals b by 2, then also it's giving negative.
So anyway, so this is
Is it necessary that you should have like we have 4 nodes and you should have 4 of
yeah, of course. Otherwise, how will you find out the? I mean, then otherwise it will not going to have your 4n like satisfy all the boundary conditions, all three other three, it has to be 0. Okay. So that's why it is like this. Okay. Yeah, we will see more basically, and this will help when we go to what is called isoparametric element, and then we will see. We will revisit these things again. Okay. Okay. But anyway, we discuss it because some insight basically, some way we are going to look at the elements and we try to guess what will be the shift function. Now, the quadratic element, where it will work, it will be one example. Quadratic. So quadratic element actually this is a rectangular element.
But,
Yeah.
sir, if we do the same thing by the regular method, then how will we get to know that it should have x square term, y square term, or z square term? By trial and error?
Trial and error. You assume first x square only, then you do find out whether you get a solution or not. If you get a solution, fine. You don't get solution, then you move to xy.
And like if you find for n1, then n2, n3, and n4 should have the same term.
Sometimes, if it is possible, if you see that something is difficult, like n1 you have found out, n2 you have found out, n3 you have found out, right? And then you don't know what will be n1, like n4. Then what you do? N4 equal to 1 minus n1 minus n2 minus n3. So you can, for example, in this case also, probably you have to do the same. This one is becoming difficult to find out, but let us say if you want to find out this one, and then what do you have? You will have n1. Start with, okay, this is n2. This is n2. Okay, n2 will be equal to, right? 1, 2, 3. N2. N2 equal to, now this is x equal to 0. It makes life very simple. X equal to 0, and what is this value? Y equal to divided 2. N2 equal to x multiplied by y minus divided 2. You get alpha. Easy? Good at, I think it's leading to a solution, otherwise. So it is a tricky, that's why I'm saying it's a really tricky. So N2, so N2 is what? You have A0 is equal to alpha, and then you have A, then you have 0 minus 2 is equal to 1, right? So alpha is equal to minus 1 minus 2 over AB, and hence N2 minus 2 over AB, x, y, 2. So you have x term and xy term. So this is how all other coefficients will be 0. Like coefficient for y will be 0 in this case. Coefficient for constant term is also 0, right? So that's possible. So N2 you have got. What is N3? N3 you get the same thing. N3 you will take this guy and then this guy, right? So N3 is equal to, let us say we write beta, and then you have y equal to 0, so y, and then you have x equal to x minus a over 2, right? And you will get N3 is equal to minus 2. You get the same way probably, right? You will get a b y x minus a over 2. You will get the same thing, right? N3 is gone. Now N4. N4. So you have like this, very easy, these and this. So gamma xy, right? And you see that N4, A over 2, B over 2 is equal to 1, is equal to gamma A over 2, B over 2. That gives you gamma equal to 4 over AB. And hence N4 is equal to 4 over AB xy. And what is N1? N1 we found so difficult, but it's easy now. N1 equal to 1 minus N2 minus N3 minus N4.
But why couldn't we take earlier N1 to be x minus a by 2 and y minus b by 2? If you have all the terms.
Say again, why not?
So x minus a by 2 and y minus b by 2. Why didn't we take that as well?
We are finding out N1, no?
Yes, sir.
Now, Nika, can you do it right now? Using this method, what I'm saying is easy to formulate for 2, 3, and 4, but not for the first one. For first one, it was not obvious. We tried to do it, but finally we could not get. But we can find out, for example, here, see here. We had something in our mind. What we had that we should not have x square term, we should not have y square term, but x y term. And hence we formulated such a way that it will have x y term as far as the quadratic term is concerned. We avoided by design x square term and y square term, but we allowed x y term. And that's why we have x y term here, here also x y term, here also x y term, here also x y term.
So but x minus a by 2, when we multiply with y minus b by 2, we won't have x square and y square term.
Okay, how will you formulate for this one? That I'm asking. For this one, you are saying x minus a over 2 multiplied by y minus b by 2. That you are saying.
Yes, sir.
Okay, but like the method we are talking about, that we see the line passing through those. Can you fit that here? The stone doesn't fit here. You are right. Finally, the equation will be something like that only. But doesn't fit the story that I was telling, that you look for two equations passing through the other nodes and you multiply them. It's not obvious whether it should be like that. You are right that actually it should be like that only. In fact, when we look at the four nodal element, that's what we will write. We will write the same thing. So in that case, what we do? In that case, we do the ones which are easy, and then the last one remaining, we say n1 equal to 1 minus n2 minus n3 minus n4. Automatically, it will have x, y, and constant terms, because all others are in those terms only. And you get that. Follow?
Could we consider that for the n2, n3, and n4 term, x square coefficient is 0?
But why? I mean, it will be 0, of course.
If we are going through this method, the method we find the n1.
Yeah. Now it has come. Sorry guys, it disconnected. Put volume 0. Volume 0 कर दो, mic 0. Yeah. So what will be the actual solution? That the best method is, as we discussed earlier, you assume a polynomial, you try to find out the coefficient, so yeah, and you will get it. If somehow you are not able to do it, that means it's not working. You have to change from x square to xy, then you see how it works. And it does works fine, then you go to answer, right? This is how you do. As simple as that. However, this I'm telling you just the insight. I'm giving my own insight. This is not from the book. I'm not telling you.
By solving it's coming, the xy term will, the coefficient of xy term is coming 0. So I'm just making.
Coefficient of xy term is coming 0.
Yes, sir.
How? How?
So it is like minus 4x square.
In N1 you are saying.
Yes, sir.
How N1 possible?
It is possible in
How possible? It's possible. Yeah. Coefficient of xy term is equal to 0.
Yes, sir.
Yeah. So that means, Aditi, what you thought that you can write N1 in terms of x minus a over 2 and multiply y minus b over 2. You cannot do it. It's not possible then. So then you cannot express N1 as this.
It's not passing to other modes.
Yeah. So it will have x, y terms, maybe, but not. So anyway, so automatically it will give you that. Okay, guys. So anyway, I think similarly you have some other kind in quadratic. Let us say you have the quadrilateral like this, rectangular, for example. So you have 0, 0. You have a0. You have ab. And you have 0b. Yeah. Okay, and this is easy here. So this 1, 2, 3, 4, and 1. xy is equal to 2 lines, as I said, right? So I will take this line, like 2 lines like this, right? So this will be x. I will write alpha x minus a, because x equal to a, this one, x equal to a, this is y equal to b, and then y minus b. So this is n1. And you know that n1 0, 0 has to be equal to 1, 0, 0 equal to alpha minus a minus b is equal to 1. So alpha equal to 1 over a b. And you know in that case that n1 xy is equal to 1 over ab x minus a y minus b. Right? Similarly, you can do for others. Automatically, you see here it will have xy term. Automatically, here you don't have x squared term. Right? You don't have xy here it was easy to do, and for others also you can write same thing. N2 equal to beta, and if you are looking at this one, then you have 2 equations, 2 lines, this and this. Right? So this equation is x equal to 0. So you write x minus 0. This is y equal to b. Right? So this is equal to beta x y minus b, and that n2 a0 is equal to 1 beta a 0 minus b, right, is equal to 1. So that tells us beta is equal to minus 1 over ab, right? And that's why you have n2 into xy is equal to minus 1 over ab x y minus b. Right? Similarly, you can have n3 xy. It will look like 1 over ab and xy. You can do it, right? Why? Because this one, two lines, right? This x equal to 0, y equal to 0. This x equal to 0, y equal to 0. Right? And it one so will be like this. And 4 xy. Either you can do add them the other two, 1 minus n1 minus n2 minus n3 you do. Right? So you can also do like this one, or you can also will have the form of minus 1 over ab, then you will have y x minus a. It will be something like that. So, right? You put x equal to 0 and y equal to b. So ab minus a is b. So this is how it would be like this. Yeah. Okay. You can also write like some other way, like you can say you can write n1 x y is equal to n. You can write nx x and ny y. Right? You're writing 1n. What is the meaning of that? Meaning of that you can have linear n1, right? So this is what you have is this one is n1, nx1, right? nx2. So 1 minus x over a multiplied by x over, this is the n1. So this is x, how it is going, and similarly this is ny1 y ny2 y, right? So first one is what? This one here going 0, and then this also you multiply, right, in y1. So that means 1 minus x over a, then you have 1 minus y over b. So that when you have 0, 0 put, you get 1. So this equation you get. Yeah, so that match, you get this original one, it will match. Then n2 xy. So n2 is here. So you get nx2 nx2x multiplied by ny. Still this one is there. So ny1y. So x over a multiplied by 1 minus y over b. Two linear shape function, you are multiplying. So you also think that way as your book has more like this. But you can also think that way, and similarly, and so on. And so on, you can do it. Any question, guys? Those online? I can spell it out also. Here. n3 xy equal to nx2x ny2y is equal to x over a, y over b, right? And n4 xy is equal to, you have n x1 x multiplied by n y21 equal to 1 minus x over a multiplied by y. Right? Get it? Any question, guys? Any question? Any question? Okay, so if no questions, time is also up. So I will see you guys on Wednesday. Okay, we will have tutorial class for. We'll continue with chapter 6 tutorials. Okay, see you guys.